Hey guys, if you have an Aloris tool post on your lathe, chances are you've discovered one of these little holes in the back side of the post. That hole is located on a non-functional side. At least that's maybe what you thought right up until you watched this video. I'm going to show you a use for that I came up with a while back, and it came in real handy. It's not something I use all the time, but when the application suits, it fits just perfect. Let's take a look. Alright, the task for today is to make, let's say, 100 shims out of this particular material. Or maybe you're even blanking off material for an upcoming job and it's just quicker to part them off than it is to do anything else. Well, I'm going to show you the very first thing that I do to set up my parting tool. And it's quite simple. All I'm going to do is drag a scale, a straight edge, a razor blade, a nice tool bit, whatever, across the face of the part in the collet, and I'm going to listen for it to click or ring or catch on the parting tool as I move the carriage towards the headstock. Just like this. As you move the scale up and down on the face of your part, if it's not hitting the parting tool, it's going to slide freely. When the parting tool's there, it's going to catch. So you just want to bump the carriage in slowly until you can just barely feel whatever you're using clicking off the edge of that parting tool. And I hope I'm not blocking the camera, because this is a really good way to do this. And we'll just bump it in until it drops, and then I'll work my way back and just, there you go, like it right there. This is the point where you would set up your indicator on your carriage with a no-go arm or magnetic base or whatever, and watch for your carriage movement to determine the size of your washer. Let's say we're going to go with an 060 washer. I have a digital readout on my carriage, so I just moved my carriage 60 thou. Now cutting the first one off is not a problem. When you go to cut the second one off, you can either calculate the size of your tool and the width of the groove and the part and stack it and do a whole lot of math and just continue to move it in, resetting your indicator each time, or you can set up a stop. And that is what I use that hole for. When you set your stop, you want to make sure that your tool is pulled away from your material and the stop is set on the back side of the part. There's my stop right there. Now let's unloosen everything. I love saying that because I know it's going to piss somebody off. I'm going to move the parting tool off the part. Okay, I'm about 1/4 of an inch away from the material. I'm going to mess around with the whole setup because the whole thing floats. I like the main mount. That's locked down. Now I'm going to go for the secondary, which is going to give me my in-out projection. I want to locate this stop on the back side of the part, and there's a really good reason for that. And the reason is so that when it parts off, the stop is clear of the work. Alright, let's try that. And then the telescopic arm itself. Snug everything up. You are good to go. Let's reposition that camera for just 1 second so you can see how everything is set. There's nothing critical about this. This is a mill vise stop that I adapted by making this little block right here to go onto my Aloris. You can see that the stop on the part is on the back side of the part, and I'm going to crank the parting tool in here just a little bit. And you can see that as the parting tool approaches the work, the stop moves away. And now the difference between the inside of the parting tool, this side, and the tip of that stylus is set for the thickness of the part you want to do. So all you need to do is just draw back on the cross slide, make a whole bunch of cuts, and let's see how fast we can drop these pieces off of here. Okay, set the camera up in the back. I'm going to go for it. And there are many different schools of thought on this particular setup. You can use a roller, you can use a soft tip, but my carriage is pretty smooth, and I'm going to put my finger on this, and when it starts to get close to the front, I can actually feel this start to vibrate. And when I feel that vibration, I'm going to call it a day, lock the carriage off, and part the pieces. But let's see how quick we can do that. 770 RPM, 7/8 diameter brass, high-speed parting tool, 060 wide shims. This is a 1/2 inch diameter hole in the part already. Okay, because I know somebody's going to make a comment about it, this is the situation that you have when you're parting your tool off. Now that is a pretty clean little top hat we're making here, and I'm going to guess that if I squeeze this, that I can get it to break off. But the best way to handle this is to have this remnant chunk left behind on the face of the part. It's just easier to continue through with the parting tool and knock it off. That being said, I'm going to take the face of this tool and I'm going to put a very mild grind on it, very mild grind, so that the first part to break through is on the part dropping off. This will take 10 seconds to do on a grinder. I'm going to approach the next cut very slowly, and I want you to see if you can see the track that the parting tool makes in the OD of the part. It should start off as a line closest to the face here and then spread out towards the headstock. Watch for the line about 60 thou in. See it? Now as I proceed to push the tool into the part, it's going to get wider. Now this just tells me that this is going to drop off clean now with no attached burr. So long as you take it nice and easy as you're breaking through, it should break off clean. There you go. No secondary deburring on that part, because the burr is left behind. Now all you need to do is just push through with the tool, away it goes. Lather, rinse, and repeat. It sends you quite a clear signal when it makes contact, and you don't have to mess with any mat. Let's reposition the camera, put a micrometer on these parts, and take a look at exactly how accurate that is. All right, let's take a look. Should be right in the neighborhood of 60 thou. I would say that's pretty close for a part off piece. 59.5. 59.5. About 59.7. So far we have a half thou deviation on parted pieces with a hard stop. It's about 59.8. 59.9, 59.8. Here's one of the early parts. Plus, it is very possible that the thickness was affected by the angle grind. Very possible. I did not reset the tool after I did that, But you can see how that works, guys. That is a great way to make a bunch of equal length parts pretty quick. Let's take a look at the stop and sign off. Okay, the stop that I just used, dirt simple to make. This is about a 3/4 inch square piece of 6061. I believe this is a 3/8/16 bolt. Those holes in those Aloris blocks are usually not very deep, so if you try to force the screw in, you're going to damage the front. So make sure whatever screw that you use, space it up or cut the screw down so that you get the grip that you need without bottoming the screw out. I have one tapped hole in there, and the tapped hole is driven by the size of the slot in my mill stop, so I can get some tremendous adjustment out of this. I have a 1/4 inch and a 5/16 hole going through here, so I can use different size rods depending on what the application is. A single 1032 screw that I move from one side to the other, and that's it. This is about 3/8 by 3/4. Yep, 3/8 by 3/4 cold roll. 5/16 diameter rod used on this one. 1/4 20 screw. 1/4 20 thread. Simple, quick, easy, and boy, it saves you a lot of time and aggravation. When you need it, you're going to be glad you got it. Thanks for watching.